Good morning. I am AAROMAL Kumar of Group 15, here to present the first topic of our design project, that is self-healing concrete. First, introduction. Concrete is the most common material that is used in construction. It is a non-linear, non-elastic, and brittle material which is used widely in the construction of buildings and civil engineering structures due to its low cost, flexibility, durability, and high strength. It also has high resistance to fire, but crack formation is one of the most common phenomena in concrete. Natural processes such as weathering, faults, human activities creates cracks in concrete structures. This affects its durability. Many research works are carried out for the modification of concrete to make it more durable, strong, user-friendly, and environment-friendly. Different materials like fly ash, carbon fibers, blast furnace slag are combined with concrete to enhance its properties. The world is now getting advanced in the field of construction, and researches are being made to improve the concrete behavior by the addition of microorganisms. Self-healing concrete. Firstly, what do you mean by self-healing material? Self-healing materials are artificial or synthetically created substances that have the built-in ability to automatically repair damages to themselves without any internal diagnosis of the problem or human intervention. Self-healing concrete is a concrete which heals itself when it comes in contact with air and water by producing lime on the outer layer of concrete. It will biologically produce limestone to heal cracks that appear on the surface of concrete structures. Selected types of bacteria, along with calcium-based nutrient known as calcium lactate and nitrogen and phosphorus, are added to the ingredients of the concrete when it is being mixed. In most of the traditional concrete mixtures, 20 to 30 percentage of the cement is left hydrated. If cracking of the concrete occurs, unreacted cement grains may become exposed to moisture penetrating the crack. In that case, the hydration process may start again and hydration products may fill up and heal the crack. Necessity. Concrete is a non-linear, non-elastic and brittle material. It is strong in taking up compression but weak in taking tension. Hence, normal concrete fails very easily through the tension zone. Plain unreinforced concrete is unsuitable for many structures as it is relatively poor at withstanding stresses induced by vibrations, wind loading, etc. Hence, to increase its overall strength, steel rods, wires, mesh, or cables can be embedded in concrete before it sets. This reinforcement, often known as rebar, resists tensile forces, but it has a tendency to undergo corrosion. RCC is superior to ordinary concrete but has a tendency to undergo corrosion. So, if cracks occur, water may seep in through the RCC and corrode the steel rod or wire inside. Hence, we can say that self-healing concrete is the solution to all these problems. History and development. In 1877, German biologist Ferdinand Kohn claimed that with a bacteria known as genus Bacillus, concrete could be healed. After years of research, in 2015, a team of microbiologists headed by Dutch scientist Dr. Hendrik Jonkers invented the self-healing concrete, which uses bacteria to heal the cracks. Mechanism. Self-healing concrete is a product that will biologically produce limestone to seal the cracks that appear on the surface of concrete structures. Self-healing agents can lie dormant within concrete for up to 200 years. However, when a concrete structure is damaged and water seeps in through the cracks, the bacteria gets activated from its stage of dormancy. Having been activated, the bacteria starts to feed on the calcium lactate which was added as an ingredient to concrete along with nitrogen and phosphorus. The bacteria feeds on oxygen and the soluble calcium lactate is converted to insoluble limestone. The limestone solidifies and seals the cracked surface. Oxygen is an essential element in the process of corrosion of steel, and when the bacterial activity has consumed all of the oxygen, it increases the durability of steel in RCC. The chemical reaction taking place in this process can be written as CaC3H5O2 twice plus 7O2 gives CaCO3 plus 5CO2 plus 5H2O, where CaC3H5O2 twice is calcium lactate and CaCO3 is limestone. The first picture shows the bacterial action on self-healing concrete. At first, cracks will expose the bacteria. The bacteria multiplies when the water fills the crack, and then the bacteria produces healing products. The second picture shows the before healing and after healing condition of self-healing concrete. Various types of bacteria used. There are various kinds of bacteria used in self-healing concrete. Some of them are Bacillus pasteurei, Escherichia coli, Bacillus subtilis, Bacillus coni, Bacillus bellodurannus, Bacillus pseudophormis. Selected types of bacterial genus Bacillus along with calcium lactate, nitrogen and phosphorus are added as ingredients to concrete to attain self-healing properties. Here we can see the picture of bacterial action on self-healing concrete. Preparation. There are two methods of preparation of self-healing concrete. The first one is by encapsulation method. The bacteria and its food, that is calcium lactate, are placed inside treated clay pellets and concrete is prepared. About 6% of the clay pellets are added for making bacterial concrete. The second method is by direct application method. That is, bacterial spores and calcium lactate are added into the concrete directly when mixing of concrete. The use of these bacteria and calcium lactate doesn't change the normal properties of concrete when cracks occur in the structure due to obvious reasons. Tests and results. Several tests were conducted by scientists in order to compare the properties of concrete and self-healing concrete. The first test that was conducted was compressive strength test, and the compressive strength after 7 and 28 days were calculated, and the compressive strength of self-healing concrete was found to be much greater than that of ordinary concrete. The second test that was conducted was flexural strength test, and the flexural strength for normal concrete and self-healing concrete after 7 and 28 days were also calculated. The flexural strength of self-healing concrete was also found to be much greater than that of ordinary concrete. Thus, it is quite clear that the self-healing concrete is having much superior properties than that of ordinary concrete. Comparison between ordinary and self-healing concrete. The performance versus time graphs were plotted for normal and ordinary concrete. From this graph, it is quite clear that the self-healing concrete is having much superior performance than that of ordinary concrete. Advantages. Self-repairing of cracks without any external maintenance is the most important advantage of using self-healing concrete. It increases the service life of the structure as it will automatically heal the cracks. It reduces the corrosion of steel reinforcement. It reduces the permeability of concrete. It increases the compressive and flexural strength compared to normal concrete. The bacteria used in concrete making process is harmless to human life. Then the disadvantages. The cost is higher than that of conventional concrete as it is an advanced material prepared with high technical expertise. Skilled labor is required. It can't be prepared like ordinary concrete. Scientists with high technical expertise prepare it in laboratories. Design of mixed concrete with bacteria here is not available in any IS code or any other code. Investigation of calcite precipitate is quite costly, and the clay pellets holding the self-healing agent comprise 20% of the volume of the concrete, and this may become a shear zone or fault zone in concrete. Then the applications. Self-healing concrete can be used in the construction of water-retaining structures. It can be used for the construction of underground retainers for hazardous waste. Self-healing concrete will be able to prevent crack formation and prevent the contact of hazardous waste with living organisms. It can be used in the construction of high-rise buildings and buildings in seismic zones. The buildings in seismic zones are quite prone to cracks, and self-healing concrete will prevent such activities. Then it can be used in concrete floors, tunnel linings, and basement walls. Conclusion. Hence, we can clearly state that self-healing concrete is crack resistant, which protects the concrete and reinforcement from cracks and corrosion. By doing this, it prevents water from percolating into reinforced steel concrete and prevents corrosion. Hence, self-healing concrete is the best solution for the demand of sustainable concrete due to its availability of self-repair and durability. In future, self-healing concrete is going to play the most important role in concrete technology for the construction of high-quality structures which will be affordable and environmentally safe. These are the references that were used. And that's all. Thank you.
Bamboo as a construction material. Introduction. Bamboo is a woody grass. It is the fastest growing woody plant in the world. It grows approximately 7.5 to 40 centimeters a day. They are also capable of growing 60 centimeters or more per day. However, the growth rate is dependent on local and climatic conditions. Bamboo are found in diverse climates from cold mountains to hot tropical regions. They occur across East Asia through to northern Australia and went to India and the Himalayas. In bamboo, the inner nodal regions of the stem are hollow and the vascular bundles in the cross-section are scattered throughout the stem instead of in a cylindrical arrangement. Recently, the bamboo has started appearing in designer homes as flooring, walling, and paneling material, etc. It has been used successfully to rehabilitate soil ravaged by brickmaking in India. Bamboo is a renewable and versatile source, characterized by high strength and low weight. Bamboo has been in wide usage since ancient times as a low-cost material for houses, bridges, etc. Next one is basic properties of bamboo. First one, tensile stress and unit weight. The common tensile stress in steel reinforcement is 180 Newton per millimeter square and in bamboo is 370 Newton per millimeter square. The mass per volume of steel is 7,850 kg per meter cube and of bamboo is about 500 to 600 kg per meter cube. Evidently, bamboo will be cheaper because the price of bamboo per weight will be less than half that of steel. Bamboo is able to resist more tension than compression. The fibers of bamboo run axially are of high elastic vascular bundle that has a high tensile strength. The tensile strength of these fibers is higher than that of steel, but it is not possible to construct connections that can transfer this tensile strength. Slimmer tubes are superior in this aspect too. Inside the silicate outer skin, axial parallel elastically fibers with a tensile strength up to 400 Newton per millimeter square can be found. As a comparison, extremely strong wood fibers can resist a tension up to 5. Modulus of elasticity. The elastic modulus for cellulose is 70 lakh Newton per millimeter square and about 50% of the cross section of the fiber is cellulose. The elasticity of the fiber is 30,000 Newton per millimeter square. In most bamboos, fibers constitute about 60% on the outside and 10% on the inside. Cellulose fibers in bamboo act as reinforcement similar to reinforcing steel bars in concrete. The distribution of these fibers increases from the inside to the outside. The fibers are concentrated in regions closer to the outer skin. This is consistent with the state of stress distribution when the gum is subject to wind forces. The density of the fibers in the cross-section of a bamboo shell varies along its thickness. This presents a functionally graded material evolved according to the state of stress distribution in its natural environment. Next one is durability. The durability of bamboos depends strongly on the preservative treatment methods in accordance with basic requirements. Its chemical composition should not have any effect on the bamboo fiber, and once injected, it must not be washed out by rain or humidity. As long-lasting as its pattern correlates with when properly harvested and maintained. Bamboo with low humidity is less prone to mold attacks, especially when the humidity content is less than 50%. Physical and mechanical properties of bamboo increase with a decrease in its humidity content. Bamboo also have minor amounts of waxes, resins, and tannins, but none of these have enough toxicity to improve its natural durability. Bamboo to be treated with a preservative needs to be dry to facilitate penetration. Bamboo can be dried in air, greenhouse, and oven or by fire. Next one, flexibility. Bamboo is highly flexible. During its growth, it may be trained to grow in unconventional shape. After harvest, it may be bent and utilized in archways and other curved areas. It It's highly flexible, and during its progress of growth, it is trained to grow in unconventional shapes. But after harvesting, it can be bent and utilized for various purposes, or can be utilized in agris and other curved areas. Cost effective. Bamboo is economical, and it is especially in areas where it is cultivated and cultivated and it is readily available. Next property of bamboo is earthquake resistance. It is the most important property of bamboo, which supports the statement that bamboo as a construction material. Bamboo is a perfect material for earthquake. It is lightweight and the hollow form gives much stiffness. High residual strength to absorb shock and impact. It has high residual strength to absorb shock and impacts. All 30 houses in the epicenter of a 7.6 magnitude earthquake survived without any damage in Costa Rica. The houses in Costa Rica, made up of bamboo, withstand an earthquake which measured an intensity of 7.6 magnitude. In each of its nodes, bamboo has a dividing or traverse wall that maintains strength and allows bending, thus preventing rupturing when bent. Because of this fantastic characteristic, a bamboo construction offers superior earthquake resistance. The National Bamboo Project of Costa Rica, only typical walls were tested using a static test. The figure shows a house in Bhutan that withstood an earthquake that occurred at Sikkim, measured an epicenter, measured an intensity of 6.9 in September 2011. How to protect bamboo? As bamboo has less natural durability, it requires chemical treatment for longer life. Bamboos have low natural durability, about 1 to 3 years, against attacks by fungi and insects. They are very difficult to be treated by normal preservative methods in dry conditions, since the outer and, to some extent, inner membranes are impermeable to liquids. The treatment of bamboo is therefore best carried out in green conditions. Untreated bamboo. Untreated bamboo has the following lifespan in different conditions. When it is exposed to soil and atmosphere, it has a lifespan of about 1 to 3 years. Under cover, 4 to 7 years. And under very favorable conditions, it has a lifespan of 10 to 15 years. Natural durability also depends on the species of bamboo. Pre-harvest and post-harvest precaution. These are some precautions which need to be taken in consideration before and after the harvest of bamboo. Felling during low sugar content season, felling of mature bamboo, post-harvesting transpiration, water soaking. Different preservation treatments. To enhance its natural durability and to protect it from insects, it is necessary to treat bamboo before use. For construction use, mature bamboo between 3 to 5 years old is selected. It shrinks less when dry and its starch and sugar contents are low, so there is less chance of insect infestation. Different species of bamboo have different uses. Example, the smaller bamboo species like Paisri suk can be stripped for use for weaving mats used as a substructure of our bamboo proof. The thicker, the more mature bamboo species, python and pyhawk, are used for structural columns and beams. Borax boric acid preservation treatment. Borax or sodium borate is a soft, colorless, powdery mineral that dissolves easily in water. It is a natural insect repellent and preservative. Depending on the diameter of the bamboo, different sized drill bits attached to long steel rod are used to drill into the center of the bamboo gums throughout the whole length. This is to longitudinally penetrate the bamboo's nodal diaphragms before the natural preservation treatment. Next, at the preservation treatment pool, bamboo is soaked in borax boric acid solution for 2 days to allow minerals to penetrate all the nodes and diaphragms. Here at the bamboo treatment pool, the bamboo is soaked in borax and boric acid solution for 7 days to allow salts to fully penetrate the inside meat of the bamboo. Bamboo is removed and stacked vertically so the solution can drain and be reused. After about 1 week, the bamboo is pulled out from the pool and stacked vertically so the preservation solution can drain from the bamboo and be recycled in the pool. Next step is that the bamboo poles are left to bask in the sun for 1 week depending upon the amount of sunlight. Then the bamboo poles rotate daily to avoid cracking. The sun bleaches the bamboo to natural golden bamboo or concrete interface. One effective treatment is the application of a thin layer of epoxy to the bamboo surface, followed by a coating of fine sand, yellow color that is more attractive as bamboo construction material. As a bamboo construction material, as a last step of bamboo treatment, the bamboo poles are left to dry slowly in a cool, dry place until they are used for construction. The figure shown here supports different methods involved in borax boric acid preservation treatment. Next one is neem seed oil treatment. Oil obtained from neem seeds can be used to improve water resistance and dimensional stability of bamboo gums, particularly at high oil treatment temperature. The water resistance and dimensional stability of bamboo gums can be increased by treating bamboo with oil obtained from neem seeds. The bamboo samples soaked in hot neem seed oil at 60 degrees Celsius for 4 hours at better water resistance and dimensional stability than samples soaked in oil at room temperature for 24 hours. The graph represents a comparison of bamboo which is soaked in hot neem seed oil at 60 degrees Celsius at 4 hours and the bamboo soaked in oil at room temperature for 24 hours. Next one is the protection of bamboo in case of bamboo reinforced structures. During casting and curing of concrete, reinforcing bamboo absorbs water and expands as shown in figure A. The swelling of bamboo pushes the concrete away, which is shown in the figure B. Then at the end of the curing period, the bamboo loses the moisture and shrinks back almost to its original dimension, leaving voids around itself, which is shown in the figure C. The differential thermal expansion of bamboo with respect to concrete may also lead to cracking of the concrete during service life. The swelling and shrinkage of bamboo in concrete create a serious limitation in the use of bamboo as a substitute for steel in concrete. To improve the bond between bamboo segments and concrete, an effective water repellent treatment is necessary. The impermeability treatment of bamboo is affected by almost 3 factors: the additional properties of the substance applied to the bamboo and concrete, water repellent property of the chosen substance, and the topography of the bamboo or concrete interface. One effective treatment is the application of a thin layer of epoxy to the bamboo surface, followed by a coating of fine sand. Use of bamboo in construction. Bamboo can be utilized as a building material for scaffolding, bridges, and houses, etc. Bamboo, like true wood, is a natural composite material with a high strength to weight ratio useful for structures. Bamboo has a higher compressive strength than wood, brick, or concrete and a tensile strength than rival steel. Bamboo can be used as a building material for scaffolding, or it can be used as a reinforcement, or it can be used for the purpose of roofing, walling, or can be used for the construction of doors and windows, etc. First one, flooring. The flooring may be at ground level and therefore consist only of compacted earth, with or without a covering of bamboo mating. The bamboo flooring can be used. Bamboo can be used as a material due to its better wear and tear resistance and resilience properties. Wall acts and a floor covering is done using bamboo boards, mats, etc. by means of wire to the frame. Various types used are small bamboo gums, split bamboo, flattened bamboo, bamboo mats, bamboo plastic composites. Small bamboo gums, they directly tied and nailed together. Split bamboo gums are split along their length into strips several centimeters wide. Flattened bamboo, formed by splitting green bamboo gums, removing the diaphragms, then rolling and flattening them. Bamboo mats. The silvers are woven into mats of different sizes according to the available hot press plates and users' demands. In construction using bamboo mats, phenolic resins are employed. Bamboo plastic composites. It is an innovative technology in which bamboo fiber is a raw material and compounded with plastic as the core material of the flooring. The ratio of the plastic should be over 30% for higher water resistance and dimensional stability. Next one is bamboo walls. As the bamboo material is light in weight, it is beneficial for earthquake-prone areas as its chances of falling are very less. Due to flexibility, and even if it falls, it can be re-erected easily with less human and property loss, with least efforts and minimum cost. Roofing. The roof offers protection against extremes of weather, including rain, sun, and wind, and it provides shelter, clear, and usable space beneath the canopy. Plastered bamboo. A cement plaster with or without the addition of organic fiber is traditionally applied to bamboo roof to get stronger roof covering. The simplest form consists of a bamboo purlin and beams supported on perimeter posters. Corrugated sheets made out of bamboo are also used as roof covering. Scaffolding. The properties of bamboo stress resilience, shape, and strength make it an ideal material for the purpose. Because of the favorable relationship between load-bearing capacity and weight, bamboo can be used for the construction of safe scaffoldings even for very tall buildings. Bamboo reinforcement. Bamboo is found in abundance. They are resilient and hence these can face the demand as a reinforcing material and become an ideal replacement for steel. A new method has been developed for incorporating bamboo into reinforced concrete, making it a more effective replacement material for steel when it comes to shoring up structural strength. When compared to steel, the strength of bamboo is greater, and the bamboo is easily accessible, and the cost of construction is less, and bamboo can crack and deflect more than steel reinforcement. Application of bamboo in various projects. These are some way projects which are completely made out of bamboo. First one is a hotel, Milka Hotel in Slovenia, which is completely made from bamboo. Next one is a restaurant in Hangzhou, which contain interwoven bamboo from the ceiling to the walls. And next one is a school, NATO High School in the Philippines, which is made from bamboo, which was primarily designed keeping in mind the strong tropical winds that sweep that area. Next is also a school in Green School in Bali. It is one of the green schools in the world where education is taught in the labs of environment. Advantages: low cost and environment friendly, lightweight compared to steel. Its circular form and hollow sections make bamboo a light building material which is easy to handle, transport, and store. Therefore, building with bamboo saves time, shock absorbing, and thus earthquake resistant. In each of its nodes, bamboo has a dividing or transverse wall that maintains strength and allows bending, thus preventing rupturing when bent. Because of this fantastic characteristic, a bamboo construction offers superior earthquake resistance. It uses less fossil fuel to manufacture. Bamboo can prevent pollution by absorbing large amounts of nitrogen from wastewater and reducing the amount of carbon dioxide in the air. Bamboo is non-polluting and does not have crusts or parts that can be considered waste. Its abundance in tropical and subtropical regions makes it an economically advantageous material. Bamboo can be utilized for permanent and for temporary construction. The composition of the fibers in the walls of the bamboo allows it to be cut lengthwise or cross-cut in pieces of any length, using simple manual tools like the machete. Another advantage of building with bamboo is that it can be used in combination with other types of construction materials, like reinforcing material for foundations. Next one, disadvantages. It is not uniform. That is, large varieties of bamboo are found having different tensile strength. It has tendency to absorb water and also to release water on drying. Bamboo wood is easily infected by wood-boring insects and attracts living organisms such as fungi and insects because of its high content of nutrients unless treated with wood preservatives or kept air dry. Bamboo is prone to insect invasion, especially when not treated properly after harvest. Hazardous pesticides are used on some bamboo, including DDT. Untreated bamboo is prone to breaking down if it comes in contact with excess moisture. It is susceptible to catch fire as compared to steel. Natural variation in species and handling mean that it may be difficult for installers to accurately gauge the quality of bamboo material. Designing and constructing with bamboo requires a special skill set that the average contractor may not possess. Conclusion. Since time immemorial, bamboo has played an important role in the development of mankind. It has been the backbone of much of the world's rural life and will remain so as the population increases. The realization that bamboo is the most potentially important non-timber resource and fast-growing woody biomass has evoked keen interest in the processing, preservation, utilization, and the promotion of bamboo as an alternative to wood. Its high valued utilization not only promotes the economic development but also saves forest resources to protect our ecological environment as a wood substitute. Since bamboo is very effective in seismic resistant, use of it should be safe. The properties of bamboo as a top grade building material and its increased availability in our country makes it possible to use bamboo in the field of construction extensively. Its high valued utilization not only promotes economic development but also saves forest resources to protect our ecological environment as a wood substitute. These are some references considered for the preparation of topics.
The design project of our group number 15 is Automatic Room Lighting System. Myself, Gayatri SERJI, and I'll be presenting the first half of this project. Let's go to the introduction. Electricity is a basic part of nature and one of the most widely used forms of energy. The electricity that we use is a secondary energy source because it is produced by converting primary sources of energy such as coal, natural gas, nuclear energy, solar energy, and wind energy into electrical power. One of the most obvious energy wasting habits is leaving the lights on, and it's also one of the easiest habits to fix. By simply turning off the lights when you leave a room or your home, you will save electricity and help your light bulbs last longer. The electricity we use is neither renewable nor non renewable, and hence we need to use it wisely. The objective of our project are Automatic Room Lighting System is a microcontroller based project that automatically turn on or off the light in a room. We often forget to switch off lights or fans when we leave a room. By using this system, we can intentionally forget about the light as the system will automatically take care of it. The aim of this project is to automatically turn on or off the lights in a room by detecting the human movement. We implemented this project using 8051 microcontroller and two infrared sensors, that is IR sensors. The materials that we used are 16 by 2 LCD display, Arduino Nano with cable, two breadboards, 9 volt 2 ampere adapter, hookup wire, CPU fan 6 volt, LED 2 or 3 in number, IR sensor module 3 in numbers, push switch for breadboard 5 in numbers, 330 ohm resistor 6 in numbers. IR sensors. An infrared or IR sensor is a simple circuit that is used to detect objects, that is proximity sensor, or measure distance, or we can call it as rangefinder. An IR sensor consists of three components: an IR transmitter or IR LED, an IR receiver like a photodiode, and a signal processing circuit. We have used reflective type IR sensor modules in this project. Arduino boards. Arduino board or Arduino is an open source electronics platform based on easy to use hardware and software. Arduino boards are able to read inputs like light on a sensor, a finger on a button, or a Twitter message, and it can turn into an output like activating a motor, turning on an LED, publishing something online. We can tell the board what to do by sending a set of instructions to the microcontroller on the board. To do so, we can use the Arduino programming language based on wiring and the Arduino software IDE based on processing. Arduino boards are widely used in robotics, embedded systems, and electronic projects where the automation is an essential part of the system.
Okay, now let us continue about the automatic room lighting system. Now we will discuss about the working. The main components of the automatic room lighting system is IR sensor. Both the sensor must be placed on the other side of the door or entrance of the room. The sensor placed on the outside of the room is named as sensor 1, and the sensor which is placed on inside of the door inside of the room is named as sensor 2. When a person enters the room, the sensor will detect the movement and the microcontroller will turn on the light and also increment the visitor counter. If there are more visitors, the microcontroller will keep the light turned on and increment the visitor count accordingly. When a person exits the room, the sensor will detect the movement and the microcontroller will decrement the count of the visitors. When the last person leaves the room, the count becomes 0. During this point, the microcontroller understands that there is nobody in the room and turns off the light. Now we will move on to the advantages. The system is completely automatic and do not need any human interference. The energy conservation. It can be used for counting purpose. It can be used for automatic room lighting control. Can be easily implemented in single door. Can work 24/7 without any problems. As well as the disadvantages, the wireless system can be unreliable. Both setup systems can be difficult to use. Badly setup systems can be difficult to use. It is used only when one person cuts the rays of the sensor. Hence, it cannot be used when two persons cross simultaneously. Expensive maintenance. They need expert for proper installation. If there are multiple doors to the same room, the project becomes quite complex. Applications. The automatic room lighting with bidirectional visitor counter can be used to automatically turn on the light in a room when a person enters the room and turn it off when the person leaves the room. The digital visitor counter can be used in various rooms like seminar hall, conference hall where the capacity of the room is limited and should not be exceeded. The project will display an actual number of persons inside the room. The automatic room lighting controller with visitor counter can be used in classrooms, study rooms in colleges. These systems can be used in our home because many times we come out of our bedroom or any other room and we forgot to turn off the room light. The bidirectional person counter project can be used in cinema hall, multiplex, malls as well as in temple to count the number of persons entering inside so that the places should not be get overcrowded to avoid congestions. Now the conclusion. Nowadays, a huge amount of power is misused in daily life due to our careless behavior. From several surveys, it is known that 1 unit of power protected is equal to the 1 unit of power manufactured. So, this misused energy can be preserved and can be contributed to the large amount of saving of power using automatic room lighting control system. Here, we have developed a controller-based model to count the number of persons visiting a particular room or a mall and accordingly the light up the room. If the count the number of persons entering and leaving the room. In the digital world, the technology is very advanced and we prefer the things to be done automatically without any human efforts. The project will be reduce the human effort and highly useful in conservation of electricity. Thank you.